Science A, Unit 6, Arrays. This is what we're going to be going over in class. This is the in-class review in preparation for your test. Arrays. What are they? An array is a named sequence of contiguous memory locations capable of holding a collection of data of the same type. So notice I have a chair collection. These are all chairs. I could have a table collection. These are all tables, and they're listed one after the other in memory. An array declaration. You state the type, open bracket, close bracket, followed by the name, okay, and that's not just name, it's the name of the array, int, bracket, bracket, my array, type name, bracket, bracket, okay. These are, oops, well, my little pen is not wanting to write. This is the template, type, bracket, bracket, name, type, name, bracket, bracket. So I could either say int, my array, double, your array. Either way, these create arrays, one of integers, one of doubles, and they are reference variables. That means your array, it's going to have a reference to some place in memory that's going to be able to hold my doubles. Primitive variables store a single value of type int, double, boolean, character, which you don't have to worry about for the AP exam. Reference variables hold a memory address. They don't hold the actual value. Array instantiation, big word. Array instantiation, okay? You give the type, bracket, bracket, and the name. That's a declaration. You haven't created anything. You're declaring, I'm gonna have. Here in the second line, this is an instantiation. Not only are you declaring what you're going to have, but you are actually creating an instance of it. So int, this is the type of each element. The bracket bracket indicates it will be an array. The num here, that's the name of the array. And then it's set to new. This creates a new spot in memory. Type integers, you repeat the type here. And then inside the brackets, the subscript tells how many of these elements. So I'm saying I want 10 ints. Now notice that 10 ints, this would come down here and it would create this little guy in memory, down here, these little green guys. And then you would have all of these would be instantiated at this point with the value 0, because I haven't given anything a value, so it takes the default. The default value is 0. Now size, this size right here must be an integer. I can't have 2.5 ints. I have an int or I don't have an int. The values held in an array must all be the same type. Okay, so they all have to be an int. Now you could, remember when we talk about fruit, okay, apples and oranges are different, but they're both fruit. So you could have a primitive, in which case it actually has to be exactly the same type, or you could have a reference, okay, to a type. You could create a particular object like fruit, in which case then you could contain oranges and apples and bananas, etc. But they would all be of type fruit. Here, int my array is set to new int 5. I'm saying I'm going to have 5 new integers. So in memory, you get a reference variable. Okay, so this is a reference, which means that it's an address of a location in memory where my 5 integer variables are stored. And they are all declared to 0 because that's the default initial value. When an array is instantiated, each memory cell is initialized with the 0 value of its data type. For ints, that's 0. For a double, it would be 0.0. Booleans are false because, oh, by the way, the binary value of false is 0. You guessed it. Using an array. You can use array variables in assignments and expressions. So I can declare an array of integers and say I've got 5 of these things. and they're all set to 0 at first, then numbers sub 0, keyboard.nextInt, I'm going to get that value from the keyboard. Number sub 1, I'm going to set that to 2 plus whatever value I've stored in numbers sub 0. System.out.println, 5 times number sub 1, so whatever value is stored in location 1 will be multiplied times 5, plus 3 times whatever is stored in 0. Number sub 5 is set to 23. This is an error. Why? Remember up here, when I declared and instantiated, I declared an array, and I said that it's 5 long. Its indices are 1, 2, 3, and 4. Okay, so I only have indices 1, 2, 3, and 4. Down here, when I try to index 5, I'm trying to go to this location, and that creates an index out of bounds condition. My last index is the length of my array minus 1, which in this case is 4. Numbers is set to 23. That's an error. Numbers, okay, this variable called numbers is just a reference variable. It's an address in memory. It doesn't hold the value, the data value. It holds an address where you can find the memory or find the value. Array initialization. You can initialize an array in a couple of ways. You can have character letters and you can set it to A to B to Z. This would create an array of 3 characters. Int squares. You originally, okay, notice the curly braces. This creates an array that's got 7 different items in it from 0 through 36, okay? And you've put in 0, 1, 4, 9, 16, 25, 36, essentially squaring each one of the indices. You could also do int my squares new int 7, saying I want an array of integers of 7, and then I could build it or initialize the values using a for loop. Either one of these works. Obviously, this would be very trying if you had a lot of data, okay? A for loop is usually what you're going to use because a lot of times you're either going to create it through an equation or pull information in from a data set, from a stored data set. You wouldn't just sit there and type all the data in. Now, assignment and equality operators. Very important to understand how these work because these are places where you could get tripped up on the test in here as well as the exam. So here we have int A is set to 5. Boom. That's this guy. Then int B is set to 0. I got this guy going on. Then B is set to the value of A. Well, A is holding 5, so B gets the value 5. Then A is changed to 100. What is A? A is 100. B is 5. Primitives actually hold the value. Okay. Now, what happens when we come down here and we're talking about an array? Well, we declare and initialize array A right here. Okay. I declare and initialize it there. So A points to a memory location that then gets the values 5, 4, 3, 2, 1. B is a new array. So it creates a new array, new spot in memory, and it initializes itself to 0, 0, 0, 0, 0, because I don't give it any initial values. So it defaults to the 0 value. Then I come along and I'm saying B is set to A. Now remember that A and B are memory locations, not actual values. So what happens here is this guy, this memory location is tossed, and B now points to wherever A pointed to. Now A sub 0, that's this guy here, is set to 100. So just changes that to 100. Since now A sub 0 is 100, B sub 0 is also 100 because B sub 0 is pointing to the same memory location. When you use the assignment operator equals with reference variables, arrays, strings, objects, you get what the reference points to. Okay, so you get the address, not the values. When you use the equality operator with reference variables, arrays, strings, objects, it returns true if and only if the references stored in each of them are identical, i.e., they point to the same place. So let's look at an example. You've got arrays A, B, and C. A is instantiated, and it's instantiated right here, and it gets 5, 4, 3, 2, 1. B creates itself a new spot in memory, and it also has 5, 4, 3, 2, 1. It holds the same values, but they're in two different places. It's as if you had a $5 bill and I had a $5 bill. We each have the same amount of money, but your money is not my money. Okay? Now, int C is set to A. So I declare C, but then notice that I make C the same as A, which means it's going to get the same address in memory. So now if I just say, does A equal B? Well, A points here, B points there, so that should return false. A equals C is true. Not only are the values the same, the reference is the same, okay? Then B equals C is also false because B and C are not pointing to the same location in memory. To compare if arrays have the same contents, if you're talking about strings, you need to use the dot equals method. And arrays, you need a for loop. So here's an example. Boolean, same data is set to true. So we're going to assume they're the same. For int I is set to 0, we're going to start at the beginning. I is less than a.length. We're going to go all the way through the array, one at a time. If b sub I does not equal a sub I, we're going to set same data to false. And then go and check the next item. Notice that once it gets set to false, there's no way for it to get set to true. So as soon as you find one item that doesn't match, the answer will be false. Arrays and methods. An array reference can be passed as a parameter to a method. So public static void change me int data. Data 0 is set to 200, data 1 is set to 400. Then you have public static void main string args. We create this guy here, int x. So we would create x, and he's going to point to an array. And the values in here are going to be 2, 4, 6, 8. Then we're going to call change me, and we're going to pass it this reference. We're passing it x, so we're going to pass it the reference. So data up here receives that reference and points to this, oops, that's terrible arrow, points to the same spot. Data sub 0 becomes 200. Data sub 1 becomes 400. Now here's what happens. You pass this in. This was passed and it was a reference. When change me goes away, and when change me goes away, this reference variable goes away and we can't see it anymore. But notice that x was changed because they pointed to the same memory location. Arrays of objects. Creating an array of objects gives them the value of null, because remember, an object is a reference variable, and so it points to a location in memory. You must also create the objects by using their constructors, either with a for loop or an initialization. Here are a couple of examples. Kids, I'm going to have an array called children that's going to contain kids, and I'm going to create new kids. So this creates an array of 10 new kids, all instantiated to null because it doesn't point to anything. Now, for int I is set to 0, I less than children.length. We're going to pause for a second. My apologies, I just realized that I had made a typo there, so I just wanted to fix it. So here we instantiate an array of 10 children that are type kids, but they're all null pointers. So then through the loop, we set children sub I, so each element of children is set to a new kid, whatever that default constructor is. Kids, an array of kids, my class, I could set it to new kid. This would use the default constructor. The second kid would be Gerald, comma false. And the third kid would be Austin. And it would use the other parameter constructor. Okay? So either way, if you want them all to be generated as new kid, great. Otherwise, you can set them up individually like this. Now, be sure to complete both the multiple choice and free response portions of the practice test to ensure you are prepared for the summative assessment. Remember that you must complete the practice before you take the actual test in order for the practice to truly be beneficial in terms of your grade.